If we have to define the importance of the spring, we can take a look at the shock. The actual spring is actually always carrying the bike. Whether the bike remains high or low, when I'm braking, when I'm accelerating, how heavy I am, is determined by the spring. If I would remove the spring, the bike will be completely flat on the ground. So here I have to determine the importance. We could say 80% of the improvement and the stability we can get by using the right spring. The last 20% we get with the damper is to control the movement of the spring. But the most important bike and the part that is carrying the bike is the spring. In the beginning, 1993, when Hyperpro started, what was sold was the linear spring and the two-step progressive spring. The two-step progressive spring actually is two springs on top of each other in one coil. One has a small pitch and the other has a wider pitch on top of each other, making a dip in the angle of the rate. The idea of the founder was that he could improve that to make the continuous rising rate spring. The difference between the continuous rising rate spring and the linear spring is the way they are wound. In the linear spring, you will see that all the distances between the coils are the same. So when you press it, all the coils are moving in the same way. When I press the progressive spring, you will see that there is a smaller distance of the coil here than there is there. When I start to press the spring, the coil starts to touch and therefore the spring is becoming harder. The way that works has to do with how a spring is made.
Here you see our torsion bar. If the bar is longer, the spring will be softer. If you make this bar shorter, the spring will become harder. If I have the same length of bar, but the coil is thicker, the spring will be harder. Because there is no space in the motorcycle for this torsion bar, we will wind this bar to a coil spring. In this way we can make it fit into the motorcycle. Here you see a linear spring. If the linear spring is being compressed, you see that all the coils are moving. The force has been divided over all coils equally. In this case, you see a progressive spring. You see that the distances between the coils all are at a different step. Here you see A, B, C, and so forth. Each distance is slightly different. When the spring is being compressed, first A will start to touch. When A is touched, this means this coil is no longer active for distribution of the force in the whole spring. The coil will have become shorter and therefore the spring is growing harder. If we press the spring further, also B and C will start to touch. So the further we press the spring, the harder the rate will become. So you see, we do this with the amount of progressive coils and the distance between these coils.